So first of all, I want to show you uh, where to find our open source code. Maybe you already know it. Here on GitHub we have a repository. This is our open source repository. It contains the most important features of dotCMS. We have another repository that is private. This is the enterprise repository, and it can be opened to our clients if they have an enterprise license. Today we are going to focus only on community features, so you won't need anything related to the enterprise license. And here we have a main branch that is master. Additionally, we have another branches. Usually, we create branches by issues and branches by requirements or features. Besides, we have tags. We release a tag with every distribution release that we have. The latest and most stable release we have now is the 5.01. That's the one I'm going to be using today. Later, during the training, I'm going to explain the difference between a distribution release and our environment and our development environment. Today, we are not going to use the master branch because as this is a branch, we are changing frequently. Maybe the version today of that branch is not the stateless one. So for that reason, I'm going to work using the tag 501. So now let's talk about the technology architecture. We propose and encourage any of three architectures option that we have. The first one is the single.cms node. This is a simple way to configure .cms. It comes by default, where you have a single server to meet all your needs and demands. It represents a much simpler and straightforward scenario. Using this architecture, you can have your database, your cache, Elasticsearch indexes, and asset in the same machine. Or you can have that in a remote file system as well. By assets, I mean any kind of file, such as JavaScript files, velocity templates, PDF, Word documents, and so on. In the database, we have the content information or fields and pointers to those assets that are saved in file system. We will cover this in detail later. We also have a second option here. There is the multi.cms node cluster. This allows you to scale up your to meet demands. Those nodes actually share the same database and the same assets, but not the same Elasticsearch or cache, which are specific for each node. They also have a cache that communicates with each other. So if a piece of information gets flushed out of the cache in one of the nodes, it will automatically will get flushed out of the other nodes too. One of the main reasons people might go with the cluster architecture is because the load in their sites is very heavy and need multiple servers. This obviously gives you some redundancy and failover, so if for some reason one of the nodes goes down, you'll still have another node that is up and running and taking traffic. In this scenario, you can also have a load balancer in front of these nodes to distribute the incoming request among them. And there is a third option called the share nothing option, which is basically multiple single dotCMS nodes. And you use a feature called push publishing. I don't know if you had heard about it, guys, but here you have, for instance, an authoring server and push your changes to different servers, which have their own database servers, their own assets, so they're totally independent from each other. It gives you the scalability so you can grow to as many servers as you need. This approach is used by many of our clients, especially because you can have an environment just for testing, and once you are sure that your environment is working fine, you can push all your content to your production server. Many clients consider that this is a better way to have more control of their environment and of their content. These are pretty much the three different high-level architectures that we talk to customers about. The second and the third options are used only for enterprise clients, and the first one comes with our community version. Now, let's talk about kind of the general philosophy as it relates to the technology and architecture in the CMS, which is really designed to support custom and dynamic content. And we want to do this as efficiently as possible. We want the experience of requesting a dynamic page pretty close to ask for a static page. And one of the main ways to achieve that is minimizing the amount of database calls. And we do it through a very heavy use of indexing, using the Elasticsearch architecture, and also caching through a framework called Caffeine. Additionally, you can configure a cache using Hazelcast if you are more familiar with that technology. But by default, we use Caffeine, which is a local high-performance memory-only cache library. And between these techniques, we are able to minimize the database calls. There has been cases where the client's database crashes and they didn't detect that right away because their dotCMS size is still fully functional given the extensive caching we do internally, which is cool, of course. Also, we have two different types of caching: the page caching and the block caching. The page cache is used when you create an HTML page in dotCMS. It is very important because it is the most efficient and the most performant cache. Our system is like a big velocity engine. So what it does is to process everything it needs to render a page, and it caches that in memory. And if you have it set up, it will cache it to this as well. So how it works? When you create a page in dotCMS, for example, I have an instance already running here. If, for example, we look for a page asset, in the advanced property, there is a cache TTL. There is that is expressed in seconds. It means that for example, in this case, it is set to 15 seconds. It means that this page, when it is rendered, will be cached by 15 seconds. So in case you apply any change to this page, by 15 seconds, it will be cached until to reflect the new changes you apply to this page. This is the value by default, but you can change you can modify this value whenever you need. Okay. Additionally to that, we have a block cache. If the page has some dynamic pieces on it that will show up depending on the type of user, for example, signing in as an administrator or someone else signing in as an limiter user, both users might view different things. In this case, you can create what we call the block cache, which means that you can cache only a block of the page. So you can specify that, for example, between point A and point B, the block will be cached, and you can give it a key and also a TTL. The main point here is to understand the differences between these two caches. If you use the block cache, we still have to parse through the velocity code to find those block cache and reuse them, which means that we add some additional overhead. Whereas the page cache is much more efficient because the velocity code has already been parsed and the string representation of the page is returned. The cache can be purged for a specific page when author changes a piece of content. If you have an HTML page, in the backend, make changes and hit a workflow action that saves and publishes the content, it will automatically be flushed out of the cache for every server in the cluster. And the version of the page, a new version of the page will be generated, stored in cache and available to all the nodes because you edited the content directly in the page. However, if your page has, for example, a newsfeed widget that got a new story added by someone else, this will not mean that every page in the entire system using that widget will be flushed out of the cache because the widget itself was modified, not the page. And of course, you can disable all caching for serving pages, but must be aware that there is a performance penalty if you do that. You can set the page cache value in the backend, in the page property, as I showed you. And the block cache has to be implemented through Velocity. You can find more information about this cache in our documentation page. Here, if you go to our main page, here in resources, there is a documentation link. And there you can find information about our different cache and how to implement them. Here, for example. Okay. Okay. As a side note, please take into consideration that this block cache is only available with an enterprise license. It is not part of our community version. We also use a lot of different third-party libraries to avoid reinventing the wheel. They are all proven solution to our problem, and it saves us a great deal of time if in our environment process. For example, we use Velocity as a as a third-party library. We also work with Angular for front end, with Apache Quartz for scheduled jobs, and so on. Now, regarding the application servers, by default, dotCMS works on Tomcat 8, but we support also JBoss. In the case of JBoss, you will need an enterprise license. Regarding databases, by default, dotCMS is shipped with H2 database in our configuration, but this database is intended only for development purposes. It's enough to showcase what you can do in dotCMS for local development and evaluation, but it is not recommended at all for official production environments. In that case, you can, or I suggest you to work with PostgreSQL, MySQL, Microsoft SQL Server, or Oracle. Um, Postgres and MySQL can be used with a community license, but my Microsoft SQL Server and Oracle need an enterprise license. So that is regarding our database that we're talking about Postgres and MySQL for our community version, and Microsoft SQL Server Oracle for our enterprise version. Also, we work with Velocity to render some pages. And for performance reasons, we use Velocity version 1.7. And right now in version in dotCMS 5.0, we are using Elasticsearch 6.1.3. This is an important change in our latest release, because in previous releases we were using Elasticsearch 1. So there was a huge changes here. If you're familiar with Elasticsearch, it is a great news for you, because now we are supporting most of their features that previously weren't supported, because Elasticsearch version 1 was very limited. We use Elasticsearch in a big part of our dotCMS, because it's allow us to index content and to render all of them in a very quick way. Additionally to that, we use Hazelcast for as a transport protocol between server if you configure a cluster. Hazelcast also provides a configuration for cache in case you don't want to use the default one, that is Caffeine. And additionally, we use Hibernate, but we are discontinuing it since we are facing some performance issues in some areas. So in the new code you write, we encourage you to not use Hibernate, especially our own Hibernate, because the version we are using is really old. The replacement for framework we use, right now we don't have any replacement framework. We prefer to use a default native SQL queries. This allows us to have more control on the data, achieve better performance in the queries, and get rid of situations where the hibernization can be very tricky. In this case, we are interacting directly with the databases. And we have internally implemented some, some methods that allow us to know what database we are running in a specific time, because there are some queries that has to be that have to be specific for a database. There are specific syntax changes that we have to apply. For example, if we are working with Postgres, and we have to apply another syntax if we are working with MySQL. In addition to that, there is a lot of other frameworks and libraries we use. As I commented you before, we use Angular for the user interface and Quartz for creating schedule jobs. Okay, now let's talk about the legacy code versus the new code. To give you guys a little context about our company, long before my time, dotCMS used to be called dotmarketing. It was a marketing company that built custom websites using live rate portals that were customized according to the client needs. Creating such a high amount of sites, customizations involved a lot of work and became very complex. So dot marketing decided to create its own product, which was based very heavily on live rates, of course, and the customization they had for all the clients were coming all together. This was the beginning of dotCMS as a company, and the product we were selling now are fairly large system with a lot of features. We are really focused on providing a very flexible product that will also allow you to interface with other software and will help you create custom solutions very quickly. We are focused right now more to work as a content as a content of a service platform. The old code uses several factories, whereas the new code uses, as I told you, what we call APIs. And you can interact with them through a REST web service.